the steps in acoustic emission testing. First one is sensor place and calibration. So attach the piezoelectric sensor to test the material. Okay. So use the reference signals to calibrate the sensor for accurate detections. Second one is loading the structures. So apply the stress or the pressure to the material if active AET is used. Okay, monitor the real-time acoustic signals generated by the defects. We can have a detector. We can detect the. Before that, we must having the amplifier so that we can amplify that weak signal which is generated by the defects inside the material due to the applying the load. Okay. So signal detection and analysis. So the system records the amplitude, frequency, and locations of emissions. High amplitude signals indicate the active crack, growth, or crack defects. And these are the just if you are having the high amplitude signals, indicate means they are having the active crack, growth, or critical defects are there and they are present there. Okay. Interpretations and defect classifications compare the result with the industry's standards, okay, and then classify the defects based on the signal intensity and durations. Reporting and documentation mean the same thing. You have to just make a documentation of your analysis, what you have got, what kind of the defect is there, what kind of the size, what is the position, which where it is located, and all that we must have to make a documentation of that so that we can send to the quality control where they can take corrective actions. Okay. Now the interpretation of the defects. If what I mean, this is the type of the defects and what we can interpret with these acoustic emission signals we get over the detectors. If you have a short and low energy burst, it means they are crack initiation. If high amplitude emissions with the increasing frequency, it means crack propagation. Means crack is working. Here crack is just initiated. Here crack is propagation. Means their crack is increasing. Okay. Continuous low energy emission, it means corrosion. If the medium amplitude emission, it means the plastic deformation. I mean, the deformation has already been done, which we cannot remove to the return to their original positions. Okay. The first one is sharp high frequency signal. It means the fiber breakage. It means the composites. Okay. So fiber, if the material is a composite material, then in which I mean we know we have a composite material in which matrix and fiber. So if you have a composite material and you are getting sharp high frequency signal, it means your fiber inside the composite material has been breakage. Okay.